Alright, your code looks good. I want you to create another form. That's like your assignment for tomorrow. I'll check it out tomorrow. Still using Tailwind. So you create a whole new project and do that.
Say kindly noted. My God.
Jola, um, who else? It's mental health. It is well. Anyway, we're streaming, so we'll come and watch. So, Jola, have you installed Docker?
No, I have not installed Docker.
So, how are we going to have today's lesson?
Let me go and install it now.
I don't even have Ubuntu installed right now.
Okay, let me go and check.
Jola, but this is something that you should have done since the last class. I mean, since we started talking about Docker.
Last class I tried to install it in front of the people, but it didn't. It wasn't working.
Jola, scroll down. You see install using apt repository. That's it. No, 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 down the heading. Install using AIS. Just copy and paste in your terminal. Okay, Pure, so you have Docker installed. Can you hear me?
Yes, I can hear you.
You have Docker installed, and then what you just did there, the last command that you ran, if you look at the Docker docs, it says that you should verify that um, the installation was successful by running the hello world image. Right, so we're going to get to all of these terms. From the last class, I was talking about what exactly Docker is. So Docker is an open source tool that developers use to automate deployment of their applications, and it has several benefits.
Sorry,
It is lightweight, it is portable.
madam, please, I cannot hear you.
Are you able to hear me now?
Yes, I can hear you now.
I said Docker is an open source tool that developers use to automate the deployment of their applications.
To
You
automate
know,
the employment of their staff.
the deployment of the applications. Yannick, are you getting me
Deployment
well?
of the applications. Okay, the deployment of the applications.
Okay. But then we're going to find out what all of that means. So with Docker, right? Docker makes use of the client server architecture. I was really trying to expatiate last time, but today we don't have much time. So Docker uses a client server architecture. That is how Docker functions. And then you already know what the client server architecture is or how it functions, right? The client makes a request and then the server gives a response based on that request, right? And all of this communication is done through an API. So that's how Docker basically works. Docker's architecture consists of you have the Docker daemon, right? This Docker daemon, for short Docker D, that is what sits there in the client server architecture as the server. And then you have the client, that's the Docker CLI, which is the client in the Docker client server architecture. And then also you have Docker's REST API. I think all of these things are on Discord. I had shared this there, so you can go and check. There's something like a small diagram there that highlights Docker's entire architecture. So just like how you know the client server architecture to be, for the Docker client, which is a CLI, you see what you did there, where you ran Docker run hello world. That there is acting as a client. That is what is able to make a request to Docker and tell Docker. When I say Docker here, I mean the Docker daemon, right? This is what makes a request to the Docker daemon, which is the server, and tells it that okay, right now I want to run this image. So what it does is that okay, as it sends that command using the CLI, which is the client, to the Docker daemon, which is the server now gives an appropriate response, right? And that you saw the first thing. Go back to your terminal. Let's take a look at it. I think it first said that unable to unable to find the client, unable to find the hello world image locally, right? And then what happens is that it pulls it from Docker Hub and then runs everything and you get this output. So all of these terms, Docker Hub and all of this, I'm going to explain them. So that is just the overview of Docker's architecture. Three parts: Docker daemon, which is a server; Docker client; Docker CLI, sorry, which is a client; and then the Docker REST API, which is what is used for the communication. That's what sits between the client and the server. A daemon, by the way, is just a process that runs in the background. Any questions so far?
No, madam.
I did not get you. Any questions so far?
No, madam, I've not understood what. I feel like you're talking very fast. When I read, I would understand. Daemon, CLI, and REST API. That's what I've gotten to know.
So what is a daemon? Let me throw the questions back to you. I want you to understand this before we move to the next part. What is a daemon? I just said it.
The daemon is the. The demon or the daemon is the server.
Okay, I started by saying that Docker uses a client server architecture, right? How does a
Yes.
client server architecture normally work? With what you know in web development, how does it work? Or in
The,
networking?
cl- the client sends a request and then the server responds.
And then the server responds. So Docker uses that same architecture. You make a request, right? And then the server responds. So now, but in Docker, what actually sits here as the client, right, is your command line interface. So
Understood.
this
Yes.
thing that you wrote here, sudo docker run hello world, that is a request that you have basically made to the server, telling it that I want to run the hello world image. I'll explain what an image is as we progress, but telling it that I want to run the hello world image. So now that you send that request, the server receives the request, right? And then it gives you back a response. This response is the output that you got after running this command.
Okay.
Okay, so that part is fine. But in this case, the server in Docker architecture is referred to as Docker D, which is short for Docker daemon. I said a daemon is just a process. In fact, a daemon is a process that runs in the background. So
That's what I said. That daemon is a server.
yes, it's the same thing that we're saying. So
Okay,
the
because
architecture,
you did not answer whether I was correct or not. That's why I did not.
Fiola, you're correct.
Thank you. Okay.
All right, so the architecture, one last time, consists of the Docker daemon, which is the server, the Docker CLI, which is the client, and then the Docker REST API, which is what is used for the communication between the client and the server. Is that
Okay.
fine?
Yes.
All right. Okay, so now we mentioned a couple of terms as we're explaining all of this, right? the first one,
Yes.
the first one is an image. Now, an image, yeah, okay, in this command, look at it, sudo docker run hello world. That hello world there is actually the image name. Now, what is actually an image? An image, in simple terms, is just the blueprint for your container to I'm going to define what a container is, right? But then an image is more like the blueprints that you need in order for you to spin up a container, and a container is a running instance of an image. So let me relate it to something else so that you can understand. When we go into OOP, for example, you have your class and you have the objects, right? So what is a class and what is an object?
What is a class and what is an object?
Yes, in object-oriented programming.
A class is an instance of class is an instance of some. Uh, can I use an example? Um,
Yes.
so you have a car and you have a blueprint of a car. The class is the blueprint of the car, and the car is the object. So a class is an instance of an object. An object is a class of the instance. No,
Ellie, are you still in this meeting? Oh God. Yola, why are you doing this to your trainer? You reversed it. You're saying that a class, are you there, Yola?
yes, I'm here.
You're saying that a class is an instance.
No, it's a slip of the tongue. An object is an instance of a class.
All right, so what is a class then?
Class. A class is a blueprint of an object. For example, a, a car.
Yola, a class is not a blueprint of an object. Well,
Okay,
anyway, we
that's
can still put it like that. We can, it's okay. We can still put it like that. I get what you mean. But then let's focus on the term blueprint here, right? So when you're creating a class, basically, you're just defining how all the objects that are going to be created or that are going to be instantiated from that class are going to look, right? Just like a house plan and the houses that are built.
Madam,
So
please, that I should not do that if I don't hear the last part, please.
I'm saying that you said a class is a blueprint, right?
Yes, yes.
Yes. So that blueprint defines how the objects that are going to be instantiated from that class are going to behave and how they are going to look, right? So methods and attributes, basically.
Mm, yes, I'm sure.
And revise OOP. So in a similar manner, you can relate this to you can relate this to a house plan and the houses that are built as a result of that plan.
Yes,
Okay.
yes.
So that's why I'm trying to bring back the analogy now to the main thing. So in a similar manner, in Docker, right, an image here is the blueprint, and then a container is an image here is equivalent to a class, and then a container is equivalent to an object. So a container is a running instance of an image. Now, what exactly is this image? This image, like we already said, is the blueprint, right? And you define these blueprints, maybe just like how an architect would use whatever tool that it is they use to design their houses, right? You, for your applications, what you use now to define this blueprint for the image, right, is called a Docker file.
Me, for my application, what I'm using to define this class is called a Docker file.
Yes, what you're using to define the image, which is the blueprint, is called a Docker file.
What I'm using to define the image is called the Docker file.
I don't know what they use, but let's just say that architects use let's just say that they use Adobe Photoshop, for example, right? That's how they draw their house plans. But then what they finally export, the image that they finally export is what is the actual blueprint to build the houses, right? So in a similar manner with Docker for your applications, in order for you to say that okay, this image that I'm defining here, right, it should have this base image. I'll come and explain what the base image is. It should have or let me say it should have these dependencies. It should make use of these requirements. It should use this particular environment. In order for you to define that, you need to use a Docker file. So the Docker file here is equivalent to the tool that the architects use to design their house plan. And then the image here is the image here is a plan that they have exported from that their tool. The plan will maybe come in the form of a PDF or an image. I not just want to use the word image two times. So far, is this part clear?
Yes, madam. Hello, hello.
Yes, Diola, sorry, I'm getting you. I was trying to talk with your trainer. Okay, so this part, is it clear?
Yes, madam.
Okay, all right. So all of this now is actually just it's just theory. So let's do the actual thing, right? Let's see it in practice. So I'm going to send you. In fact, just create an here in your terminal. Just create a directory. Maybe you can call it Hello Docker.
Madam, please, can I create it on my window, on my,
Why?
on,
Why do you want to create it there?
madam, because we're running out of time.
But you just do it in your terminal.
Madam, Wait, should I just go see you?
Till the command is correct, or you want to go somewhere else.
I want to go to somewhere else. I don't know what to go to. Okay. Uh,
Okay, go into Docker then. Go into the directory.
Madam,
Okay.
please can I now go to my screen, please?
Tiola, why don't you want to use your terminal? Everything is going to be done in the terminal.
Uh, Madam, they said that I'll do front end, so I have to get used to my computer screen.
That's not what front end means. Create a file there called app.py. Is that a command to create a file?
Yes.
So why is the response no such file or directory?
Maybe there's an error with my machine.
The cat command is not used to create a file, Tiola. It's used to view the content of a file.
Okay. Got it.
What is the command?
The command. Mother, it has to be cat and then the name of the file.
I just said that cat is used to view the content of a file. So how do you create a file?
Um, touch. Or wait, um, m- maybe make file.
Tilda is touch. And the reason why you're forgetting is because you don't practice often.
Madam, they said that I'm going to do front end, so I need to.
Doing front end does not mean that you no longer make use of Linux or the terminal. So open the file only here in the terminal. Use whatever text editor you want to use. That is to view the content of the file and it does not have any contents because Touch creates an empty file. So now I want you to actually open it like you would open on an IDE, but then within your terminal. Use whatever text editor you want to use. All right. So define a simple Flask application that has one endpoint.
Madam, you said that I should do what?
Create a simple Flask application that has one endpoint.
Hey, God, yes. Madam, can I go and look? and come back.
Go and look fewer. If you need to look, that's fine.
Yeah. Madam, hello.
I'm getting you.
Madam, please, my teacher is not going.
Your teacher is here so that you can see whether you've been studying.
I thought that maybe he wanted to go. He said that he was going, madam.
Okay, so open Discord in cohort 2. Just copy what I've sent and paste. You can just use that copy icon at the top right in the terminal. All right. So this is a simple Flask app that has two endpoints, right? So you've added something else. Save it. Save the file. What do you save with Vim? It's not Control S. You need to first of all exit this insert mode. Press Escape.
Yes.
Okay, continue. You can now save. What are you pressing to save?
Cure to exit.
But have you saved?
It will automatically save.
It will not
Press.
automatically save. Press column and then X. That would save and exit. Now if you do your cat command again, you see the content. Okay. Do you have flags installed globally?
Yes, I
Do you
can
have
see.
I'm asking if you have flags installed globally.
Um, no, no.
Okay. Just create a virtual environment and then install Flask. Definitely you have Python.
So I should go to VS Code.
No, just here within the terminal. Create a Python virtual environment.
Hey,
So this command that you're writing, what is it supposed to do?
I'm supposed to create a virtual environment. Hello, hello.
Yes, I'm getting you. Yola, that's not a command to create a virtual environment. What you're writing is the command to activate the virtual environment.
Uh, It's okay. Let me complete it. Maybe because you have not seen the completion.
Okay.
It will create it and activate it. I'm
All right.
sure.
Has it created and activated?
Maybe my Ubuntu has a problem.
Your Ubuntu does not have a problem. So this is not a command. To create a virtual environment, you need to use Python or Python 3-m venv and then the name of the virtual environment.
They have not taught us that one.
Yannick is in this meeting. So should
I
I
don't remember.
confirm with him if this was done?
Okay, I mean that I don't remember that they taught us that one. They taught us better how to activate the virtual environment.
You cannot even activate what you've not created. So create the virtual environment. Let's see.
Madam, please can you say it
Python
again? Python
Python
create
3
virtual environment.
Python 3-m. Just be writing it at once.
Python
Dash m venv space. Then the name of your virtual environment. It can still be venv or .venv, whatever you choose. Okay, that's it. So your virtual environment has been created. Now you can activate it using that source command from above. Okay, nice. So your virtual environment is activated. Now install Flask within this environment. You need to write pip install Flask.
Madam, another one. How to do?
All right. Okay, nice. So you have Flask. Now run the Flask application that you have there. You need Python 3 what exactly? Can't open because you did not specify any file name. So what do you have there that you want to run? It's app.py. Okay, nice. So your application is running. Let's look at it in the browser. I think the two endpoints were just slash and then slash greet. Has it opened or is your screen okay? Just write localhost 5000 in the browser if this is not taking you there. Okay. Then let's look at the slash greet endpoint.
The slash grid.
Yes, so just yes slash and then greet. Oh, I think this takes a name even. Okay, go back. Write localhost 5000 slash greet and then question mark name, I wasn't done. Name equals maybe Fiola or anything you want. Do you need to use quotes? I don't think so. Just write name. Yes, remove the quotes. Let's see. Name is not defined. Ah, we can look at this error later. Let's go back. Go back to the terminal. Oh. In your code, did we import requests from Flask? Import requests. Please
No,
modify the code. Okay, yeah, modify the code. That's why. Just do Control C. So you can open another terminal instance. Okay. So open the file again and then add that request there
yeah, you should open the file again.
using Vim. All right. So import requests from Flask, import Flask, then command request. Okay, save. And that should be it. Okay, you can try to run again and then test. So while you're doing that, there's something I did not mention at the start, right? So just try to listen while you're checking out the endpoint again. So Docker, aside from being a tool that helps you to automate deployment, right? One primary problem Docker came to solve was that problem of it works on my machine, and then when it reaches production, it's something else. Or it works on my machine but does not work on this other person's machine, maybe because of conflicting dependencies and all the like, or different environments as a whole, or different operating systems as a whole. Normally, we should not even talk about Docker without without talking about virtual machines. So, Fiona, very quickly, I want us to get into the practicals very quickly. What do you think a virtual machine is and how do they work?
A virtual machine. A virtual machine. Virtual machine. It's a machine that you cannot see and touch, but okay, if it acts like it replicates the workings of an actual machine.
It replicates the workings of an actual machine. Oh, in a sense, yes, that is correct. That is correct. So a virtual machine is still a machine that does not. How do I put it? That does not require any physical hardware. What I mean is, you don't need to go and buy another. In fact, it's the opposite of a physical machine, basically. So this virtual machine, right? Um, Its primary purpose actually is for sandboxing. Now, sandboxing means okay, you're testing your software in different environments, such that you prevent malware from spreading into the system. That is one of the primary reasons for virtual machines. Okay, but now to give a clearer definition, um, a virtual machine is basically. Are you still getting me?
Yes, I'm getting you.
All right. So a virtual machine just simulates a physical machine. Yes, I think that's a better way to put it. It just simulates a physical machine. So the virtual machine that or the virtual machines that people use um, are referred to as what ones on their main PCs, which is what we refer to as the host here. Once it's on the host, right? When once you install a virtual machine or virtual machines, you will now refer to them as guests. Okay, so you can have many virtual machines running simultaneously on your host PC, that's on your physical machine, right? And all of them, each of them are independent of each other. So Docker actually inherits this concept or this principle with virtual machines where they are independent of each other, and we refer to this as isolation. What happens in virtual machine one does not concern what happens in virtual machine two, and so on. Okay. With virtual machines, also when you're running them, they share the host's resources. So if you have, say, 32 gig of RAM with 1 terabyte SSD, for example, if you're running a virtual machine, the virtual machines know that those resources are now going to be split with the virtual machines, because the only difference here like I said, it's simulating like your actual physical machine, right? So definitely it must make use of your RAM, it must make use of your storage and the other resources that your computer has. For you to spin a virtual machine, you need to make use of what we call a hypervisor. In your notes, you're going to see more on virtual machines, but I just wanted to put this on the table so that you understand. Now, let's say that one use case, let's say that you're building a desktop application, for example, and you're trying to build, okay, let's take, for example, VS Code. You want to test VS Code running on Linux. You also want to test VS Code running on Windows. You want to also test it running on Mac and so on, right? So instead of you now going to purchase three different physical machines with three different operating systems, what you can do is that you're just going to spin, let's say you're on a Mac, right? You can just spin a Windows virtual machine and a Linux virtual, and you're able to test your application in that environment using that operating system isolated as though it were on an actual physical machine. So you see where the whole concept of testing comes in here. Now, um, with Docker, right? Like I said, Docker actually inherits this property of isolation from virtual machines, and you're actually going to see it here. With Docker, irrespective of your operating system, irrespective of what the kind of environment you have set up on your computer, the moment you run an image, is going to run without any disruptions. Why? Because it comes in what it comes in a container that I don't think that name was there for just any reason. It comes in a container, meaning isolated, everything packaged into one, such that it is convenient for you to run that application. Okay, so let's go back to the terminal. Let's look at the Flask application. This is your application which you've built, right? You have two working endpoints which you said. This application now runs normally on your computer. Now, let's say that another developer were supposed to set up this your application. What are the things that they are going to be required to do in order for them to also run this application the same way you're running it on your computer now? Viola, did you get me?
Yes, I'm thinking, madam. They need. Oh, the term that is coming to mind is dependencies. Well, they need to install. They need to
Yeah, just
install
explaining
Docker.
how you can.
They need to do what I did. First of all,
Then
have Docker installed. And please, what was your question? For them to run or make edits to this thing that I've done, what do they need?
yes,
They
yes,
need
this
Python
Flask
installed.
application.
They
Yes.
need
What
Python
else?
installed. They need Flask to be installed. They need a virtual environment, and they need to activate the virtual environment. And
Okay. Well, they don't necessarily need a virtual environment, but they need Python and Flask installed. That is the main thing. Excuse me. That is the main thing. And then they'll also need to go and, of course, clone this repository. Okay, but now let's see how Docker can actually solve this problem, right? So open another instance on your terminal, like open another page.
I should open another page. Where's another page?
Okay. Sorry, Theola, I got disconnected. I was saying you should click this plus button on your terminal. Have you opened another page?
Yes.
Okay. So you're still within the repository where your Flask application is, right? Okay. So now create a Docker file. So just do touch Docker file or vim Docker file. So it just opens it up for you. Capital D. Well, with small D does not have an issue, but let's respect their rules. Docker file is one word. File. Yes, Docker file. Yes. No, you don't need to add .txt. As it is like that, even without that .txt extension, it is already. In fact, it's a text file without the .txt extension. You don't necessarily need to add it. So remember what I said at the beginning, right? That when an architect uses maybe Adobe Photoshop or whatever tool that they are using. Okay, I think AutoCAD is coming to my head. I don't know what it's used for, but I feel like it's related to them. So when they use AutoCAD, for example, to draw their house plans, and then the house plan that they finally come out with now, which is maybe as a PDF or as an image, right? That is the output. That is the template that they are going to use, right, to build these houses. So now for your application, we also want to use the Docker file, which is our tool, right? We want to use the Docker file, which is our tool, to define our image, which is our template slash blueprint, right? Okay. So, Piola, you said that the first thing that they need is to have Python installed, right? So we're going to
Yeah.
define this now within this Docker file. So write from in capital letters.
That I should write from.
Yes, write the word from in capital letters. Okay. And then what Python version do you have installed?
Python 3
3.1.
version. I don't know. Let me check.
Uh,
Please.
anyway, it's okay. It's okay. It's okay. So write from Python column 3.12. I'm sure what you have should not be less than 3.12. Okay. So this from command, right? What it does is that it's basically defining the base image that your application is going to use. Okay, so remember an image is a template, right? That you use to or a template that defines how your application should function when it is run. That's when you spin up a container from it. or that defines all the dependencies, all the packages, all the requirements that is necessary for your application to run. That is what an image is, right? But now for us to create that image, we need this Docker file. So what this from command does is that it specifies what we call a base image. A base image is still an image. It's just basically saying that, okay, no, this is the parent image. For me to define the image for my application, I must start with an image of Python because that is the main dependency that I have. Is it clear? Should I try to re-explain it?
No, it's clear.
All right. So this defines your base image. Okay, so you're basically just specifying the Python version there. So after that, from you skip a line. It can all be skip a line, like give an empty line so it looks neat. Now write the command walk d, like walk and then d for directory. Still in capital letters, please, like the from command. One word. One word. Walk dir as in directory dir. Okay. So you can do no Tiola. Walk the one command. Capital dir, no space, yes. dir. Yes, now space. Okay. You can what this basically does, this command here just creates a new directory, right? Just like you have make div. It creates a new directory and it goes into that directory. It cds into that directory. So now the directory name can be anything. You can call it slash app slash docker slash whatever. All right. So we've created a working directory. Now on another line, the next command we're going to be using is the copy command. So write copy. Okay, so this is how it goes with the copy command. You have copy and then source, then destination, right? So you're specifying where you want to copy this file and where you want to deposit it or make keep the copy basically. So now you're going to write copy dot and then dot is your source space and then slash app is going to be your destination. Okay. So so far, Fiola, from the work from the from command right up till this copy command, please re-explain it back to me what it does.
The from command is telling you that you are taking from the base directory,
Base image. So
base image.
in a simpler way, you're just saying that this is my main requirement or my main dependency for this application to run.
Okay, so a from command shows you the main dependency for this application to run.
Yes. What about workd?
Workd shows you the directory in which you are working in and then the
Okay.
name.
It creates the directory basically. Just like you have make d, right? For
Yeah.
Docker, it is workd, so it creates the directory
Okay, the second one
that is
is
going
the
to exist
directory.
within. Okay, go ahead. It's okay.
The second command workd creates the directory which is going to exist within the project.
Yeah, and then the copy command.
The copy command starts from the source, which is the dot, and terminates in the slash app. So we're copying from the source to the app.
So that dot, what exactly does it represent here? What is the source even? What does that dot
The
mean?
source is the image from above.
It's not the image from above. Okay. So the copy command here, sorry, the dot here represents your the context within which your Docker file sits. So your Docker file is sitting inside the Docker repository, right?
My Docker file is sitting inside my Docker repository. Yes.
Yes. So when you're saying copy dot, you're basically saying that everything within this context where this Docker file is seated, so everything here basically means app.py, right? So copy app.py from what I have locally into /app within the instance of the container that will be running. We'll come to containers, but then that is what it basically means. When we run this thing, we'll come back again. Let me see. We'll run this thing, we'll come back again and then review the concepts. Okay, so the next command after this copy is going to be run. Run, the run command. Okay, so this run command, um, it gives you the ability to run a command as though you were running it in your terminal. So you see all of those commands you use, ls, this, that, and so on, right? This is what the run command enables you to do. So, we did not even create a requirements file, but then it's okay. Think of a normal Python project, right, or a Flask project.